All right, in this video, we want to find the equation of a linear function that passes these 2 points, an exponential and a log function. So let's start with the linear function. I know the equation of a linear function is just y equals mx plus b. So I'm going to start by finding my slope by doing y2 minus y1 over x2 minus x1. 0 minus 2 over 5 minus 0. Just negative 2 over 5. I'm going to rewrite my equation as y equals to negative 2 over 5x plus b. I just filled in my slope there. Next, I'll find my b value by just subbing in a point over here. I'm going to use the point 0 and 2 because that's going to make it a lot easier. I'm replacing y with 2 and x with 0. Negative 2 over 5 times 0 is just 0. So b is just 2. So my linear equation passing through those 2 points is y equals to negative 2 over 5x plus 2. Next, let's do it for an exponential function. So I'm going to draw this out. I'm going to sketch it out because sketching makes things a lot easier for an exponential function. So 0 and 2, x value 0, y value is 2, and then 5 and 0 is here. There's a couple of different ways you can do exponential functions, but I'm just going to do a graph that looks like this, basically. I'm going to select my horizontal asymptote to be y equals to -1. You want to try and pick it as close to the points as possible. That's why I picked -1. You could also do -2, -3 as well. -1 will likely give us the easiest solution. This point is 5 and this point is 2. So for an exponential equation, my equation is y equals to a b to the power of x plus c. And if there's a reflection in the y-axis, k can be plus or minus 1. So if I pick this to be exponential growth, normally I can tell that this has a reflection in the y-axis, which means my k value in this question is going to be -1, or at least that's what I'm going to choose it for this equation. So I'm going to rewrite my equation as y equals to a b to the power of -x. That's because of the reflection in the y-axis. And I'm also choosing to have exponential growth. You don't have to include the negative there. Actually, you know what? I'll do this with exponential decay. Why not? So this can just be an exponential decay. You don't have to worry about your k value there. And then my c value is just my horizontal asymptote, which is -1. Then I'm always going to sub in my y-intercept into this equation first. So 2 equals to a b to the power of 0 minus 1. And then b to the power of 0 is just 1. A times 1 is just a. And if I add 1 on this side, I get a equals to 3. I'm going to rewrite my equation as y equals to 3 b to the power of x minus 1. Now I'm just going to sub in the other point here to find my b value. The x value is 5 and the y value is 0. So that's my equation right there. I'm trying to isolate b now. I'm going to add 1 on the other side. Then I'm going to divide by 3. And then I'm going to do the 5th root of the other side to give me my b value. So b value is the 5th root of 1 over 3. So my exponential equation for those 2 points is y equals to 3 5th root of 1 over 3. So as you can see, this is exponential decay because we didn't select a reflection in the y-axis. And then my My value here is going to be x minus 1. That is my equation there. If you picked a reflection in the y-axis, then we would have got a different b value, which would have been exponential growth with a reflection. So there are two possible answers to do for this specific question here if you pick the asymptote as -1. Always two good answers for exponential and even log equations as well. So the third one is going to be the log equation passing through these 2 points over here. So again, I want to sketch this out first. So 0, 2, and 5, 0. So if you think about a log function that passes through these 2 points, we can do a log function that looks like this. And then if you want to pick your vertical asymptote, you can pick your vertical asymptote to be anything you want. So you can pick it to be 6, you can pick it to be 7, you can pick it to be 8. I'm just going to pick it to be x equals to 6. So now if I want to find the equation for a log equation, it's y equals to a log b x minus c, or d, I guess, plus c. And in this case, k can also be plus or minus 1. You can, again, there's two possible answers over here. If you don't want to keep a k value, you can make your base as a fraction, but if you keep a k value, then I guess you can flip your base or things like that. So I'm just going to have a k value for this one. So I know an original log function looks like this, which means this log function here is going to be reflected in the y-axis because it looks like this. My k is going to be -1 for this equation. So y equals to a log. The first thing I'll figure out before I do anything else is the base. To find the base, I'm going to look at the distances from my asymptote to my first point, which is 1. I guess -1 in this case, but I'm not going to worry too much about the negative. And then the distance to my second point over here is 4. No, 6. What am I saying? It's 6. Distance is 1, distance is 6. So then you're just doing this number divided by this number to give you your base. So my base is 6 divided by 1, which is 6. I've chosen for this to be a reflection in the y-axis. So it's going to look like that, negative over there. And then x, my d value is my vertical asymptote, which is 6 units translated to the right. So x minus 6, then plus c. Then we need to find a and c by subbing in the first 2 points. I'll always start with the first point here. My y value is 0. And my x value is 5. And then I'll just solve this a bit. So a log 6. 5 minus 6 is -1. -1 times negative is +1. Plus c. Log of 1 is just a 0, and 0 times a is 0. So 0 equals to c. Basically, c is just the y value of your first whole number point for a log equation. My equation is y equals to a log 6 negative x minus 6. And then my c value is 0, so I'm not going to include that. And now I just need to find the a value by subbing in the second point there. So y is 2, x is 0. Zero minus 6 is -6 times -1 is +6. Log 6 of 6 is 1, and 1 times a is a. So my a value is just 2. So my equation here is y equals to 2 log 6 negative x minus 6. And then there's no c value. So that is my final equation. So I've shown you how to find all 3 different types of equations: linear, exponential, and log equation from the same 2 points.